Okay, Coriolis 100 integrals number 24. So we've got this question. We need to integrate sect 3x to the power of 4. All right, so the idea behind this question here is that's to the power of 4. We need to use the Pythagorean identity of a secant square. So secant square x is equal to 1 plus tangent square x. So therefore, secant square 3x is still equals to 1 plus tangent 3x, and there's a square here. All right, so that's the idea. So what we need to do is break the power of 4 to the power of 2, and with another power of 2. All right, so we'll start with the process by separating that into 2. So we've got secant square 3x multiplied by secant square 3x dx. Once we finish that, we are going to term the second term, or the first one. It doesn't matter which one you choose, but I'm just going to term the second term into this formula here, the Pythagorean identity formula. All right, so that will give us secant square 3x multiplied by 1 plus tangent square 3x dx. Okay, so once we finish that, as you can see, I'm just using the formula. All right, to change the secant square 3x into 1 plus tangent square 3x. All right, so once you finish this, the next step we do is we need to expand. All right, just expand the brackets. So we're going to get secant square 3x plus secant square 3x, and I'm going to expand it using the large brackets. So hopefully you guys can see, okay, what does that mean? All right. Okay, so the first one, all right, just the very first one here, that's a really simple one. That's just the the standard integrals results. So that's really simple because the derivative of tangent x is equal to secant square. So we've got secant square 3x. We can integrate this one back using the reverse channel. So that one is easy to do. All right, let's separate that into 2 different parts, just in case if you can't see it. So I'm going to separate that into 2 parts like this. I'm still going to use the square bracket. Just make this one stand out, that's a bracket, and I will talk about it in a minute. All right, with the first one, I'm just going to use the reverse chain rule. The derivative of 3x is equal to 3. So what we are using is the formula here. We're using this formula. So when we integrate f dash x, sect fx, and that's a square here, dx, the answer is equal to tangent fx plus c. That's the formula we're using. So as you can see, we need a derivative of fx to be in the front here. All right, so therefore we can use the formula. So the derivative of 3x is equal to 3. So therefore I need to put a 3 in the front and 1/3 outside. Okay, plus. Now with the second part here, this part is really interesting. All right, the reason I put a square bracket is because I just want to emphasize this is the function I have. That's fx. Okay, that's the power of n. And this is f dash x, kind of like f dash x, what you need to have an extra 3 in the front as well. So we can use something called a reverse chain rule to do this, the question. The derivative of tangent 3x is equal to 3 sect square 3x. So if I put a 3 in the front here, I need to add 1, times by 1 and 3 in the front, just to cancel that. So that becomes the reverse chain rule formula. Okay, which is the formula from the previous question, but I'm just going to write it here. So I've got integrate f dash x fx to the power of n dx, and the answer is equal to 1 over n plus 1 fx to the power of n plus 1 plus c. That's the formula we're using. So as you can see, let me just highlight that for you. This fx is tangent 3x here, and this f dash x is the 3 secant square 3x. So now we should be able to integrate these. All right, so now we can integrate each term using the reverse chain rule for each one of them. So that gives you, all right, different color. That gives you 1/3, we're going to keep 1/3 here, and then tangent 3x. That's the first one. Yes, you can have plus c at the end, but we are just going to combine the 2 constants together. All right, so plus 1/3 tangent 3x to the power of 3. Now, as you can see, I left a space here. All right, the reason I left a space here is because I need to find the reciprocal of the 3 and put the reciprocal of 3 in the front. So therefore, that gives you 1 over 3, okay, plus c. So the final answer is 1/3 tangent 3x plus 1 over 9 tangent 3x to the power of 3 plus c. That becomes the final answer. Okay, so this is a pretty tough question. You need to, like, when you first look at the question here, you need to realize that this is the Pythagorean identity. You need to be able to change the power of 4 to power of 2 and power of 2. And then once you expand it, you do get 2 expressions here. With each of the expression, you need to realize that they are all reverse chain rule. Again, if you don't know how to use a reverse chain rule properly, then you have to use the u substitution. So you're going to substitute u equals to tangent 3x and then start to use the substitution method to do the question. But it's really slow if you do that. You also need to let u equals to 3x to do the question here as well. But again, if you know your reverse chain rule method, it is going to be really efficient to do the question. Okay, thanks for watching.